On a PC, the end user starts by identifying himself, and the system asks him which service he wants to trigger. The end user specifies that he would appreciate to get a doctor close to him. The system computes the possible solutions and provides a user interface that is adapted given the user's context of use. On the left, the user interface displays a list of possible doctors. On the right, a map is displayed showing the current location of the end user and indicators where the doctors are available. On the smartphone, the process is exactly the same one. First, identification, then request of a medical help, then the system displays the produced user interface, and in the same way, the user interface is adapted to the user's context of use. The list of doctors is no more provided, but tapped pen showing the possible doctors. The map has been migrated to a dedicated tapped pan. So far, you have thin plastic user interfaces, but no flexibility. That's why now we will show you what happens in the back end on the server, exactly where the designers and developers have defined the methodological activities they want to support. In our case, they have chosen several methodological variants. First, instead of creating a task model, they have enacted an alternative activity proposed by the method. They have made benefit of a tool developed in our team, which name is Compose, that generates the task model. Second, instead of creating the domain model, they have generated it from an existing database thanks to a second alternative also proposed by the method. As these models are going to be generated, we do not need them to be there at the beginning of the UI generation. As a result, we can delete them. The third methodological variant is related to the completeness dimension. It consists in choosing a default platform model that is given by the method. This model is of course simplistic, but sufficient for prototyping. When the end user launches the Find a Doctor application, the server receives a request. The server launches the corresponding transformations. First, the server generates a domain model from a database and extracts the instances from the database. The corresponding files appear on the server. Then, the server triggers the generation of the task model. That, in turn, appears as a file. The server transforms the model that is produced by Compose into a model that is compliant with the usicML language. At the end, the server executes a classical sequence that is made of the generation of the abstract user interface, then the generation of the concrete user interface, then the generation of the final user interface, and finally, the compilation of the final user interface and its deployment on a server. The URL that corresponds to to this user interface is sent to the user's device. In conclusion, the method that we have promoted in this video illustrates variants that are not covered so far by development methods of plastic user interfaces, even if, of course, some of them are practiced in an adult way, such as the use of a database, for instance. This work has been supported by the European usixml project as well as by the French Connection project. We warmly thank for their strong support.